here we're going to look at solving an equation with two radicals that reduces to a quadratic. But the biggest thing about this one is when you have two radicals, it would be nice if you could get rid of all of them at once, but you can only get rid of one at a time because you have to get the radical by itself in order to get rid of it or cancel it out using a squared. So if I add this one to the other side, it just looks like the easier one to do because it's already negative. So I'll get this square root alone, and I'll add this one to this side. So now when I square, I'm at least getting rid of one of these two radicals. The one on the left is by itself, so when I square something that's square rooted, that will cancel. But over here I have to be careful. I'm squaring something that has two terms, which means I have to FOIL. And sometimes I think it's easier to FOIL if you can actually see what you're FOILing. So instead of writing the squared, I'll scribble it out and actually write this term twice, because that's what squared means, right? It's something times itself. So now on the left, the square root and the squared cancel, so I'm just left with 5x plus 34. And on the right, when I FOIL, my first term is 2 times 2, so 4. My inside term is 2 times the square root of x plus 22. And my outside term is the same thing, 2 times the square root. And then my last term, I have a square root times the square root. So it's like, once again, a square root squared. So the square roots cancel, and I'm just left with x plus 22. And so now I could clean this up a little bit. Get the two radicals are the same, right? So I have two square root of x plus 22s and another 2. So I can get those together as like terms. And then I have my numbers that are like terms. The 4 plus 22 is 26. So I have 4 of these radicals. Kind of like when you have 2x plus 2x. All right, so now that we're down to just one square root, we want to get that one alone, kind of like we did with the other one earlier. So I'll subtract x from both sides of this equation and subtract 26. So I'm left with 4x plus 8 equals 4 times the square root. So I'm pretty close to having that alone. And then you can square right now because it's multiplied, right? It's not two separate terms. But if you notice that everything in this whole equation is divisible by 4, it might make your life a little bit easier to just divide by 4 right now. And so I'll end up with x plus 2 equals square root of x plus 22. So now I have a square root all by itself, so I can square both sides again. This is one of the longer topics, so this doesn't happen very often, but I have to erase to make myself some more room. Don't worry, we're almost done. Okay, so just like earlier, now that I have a square root all by itself, I can square both sides. And just like earlier, the left side is going to require FOILing, right? Because I'm doing x plus 2 times x plus 2. And then over on the right, the square root and the squared will cancel, so I'm just left with x plus 22. So now when I FOIL, I get a little bit easier to FOIL when you don't have the radicals in there. I get x squared plus 4x plus 4. And now I can subtract x from both sides and subtract 22. So I get x squared plus 3x minus 18. And so that looks like hopefully one that factors nicely. So I don't have to complete the square or use quadratic formula or anything. So it looks like this factors to x plus 6, x minus 3. That would multiply to negative 18 and add to 3. So I have two possible solutions here. X could equal 3 or negative 6. But then it's important that I check those in my original equation to make sure they actually work. Because even if you do all the steps perfectly correctly in these root problems, you can get what's called extraneous, just a fancy word for extra solutions. Mainly it's because when you square, you could take something that used to be negative and make them look like they match even though they don't. So it's always important to check, but it's especially important to check in these because sometimes both answers work, sometimes only one of them works, sometimes neither work. So there's only one way to find that out. You have to check on them. So let's try the 3. So our original equation, so 5 times 3 plus 34 minus the other square root, which was 1 times 3 plus 22. And we want to see if that equals 2, right? So here's my equation from the very beginning of this, where I'm putting in 3 for x. So I have 15 plus 34, so square root of 49 minus square root of 3 plus 22 is 25. So I get 7 minus 5 equals 2. So it looks like this answer works. Now we got to try the other one. And to not have to totally rewrite all this, I'm just going to erase the 3 and try -6. So we have 5 times -6 is -30 plus 34. So that'd be square root of 4. And then minus 22 minus 6, so square root of 16. And so I have 2 minus 4 equals 2. But 2 minus 4 equals -2, not 2. So it looks like that answer doesn't work. And so back to our original, that means x equals 3 is our only answer.